Welcome to episode 8 of the Cloud Code Life podcast. The whole gang is here, Alf, Rishab, and myself. And today we are covering, well, first of all, we're trying out this, format, maybe structure. We of course want every episode to have sort of like a theme as we've been doing, but we also want to introduce sort of, like a structure, maybe a series. But anyway, this episode is and you might be familiar with the term explain like 5. We sort of did something similar with the 10 cloud services that beginners should know, and we had a lot of fun sort of summarizing those, so we figured we'd give it a shot with some DevOps concepts. So that's what we're going to be talking about in this one. We've all got a few concepts that we want to go back and forth on, and who wants to start?
Well, we should start with like DevOps itself. I feel like it's a little bit of this mystical beast that a lot of people talk about, and not everyone knows what it is. So that could be a good place to start.
Yeah, probably. It's also one of those that there's just like so much, maybe not drama, but it's just so much misunderstanding around. There's also like a lot of not cult, but like sort of like a groupthink kind of vibes around the whole word DevOps. And hey, is DevOps an actual role? Is it a job that you should be getting? And then you also have sort of the these words that have like become a thing because of DevOps. You have like DevSecOps, DevNetOps, that kind of stuff. So let's, I guess that's a good place to start. So DevOps is a set of practices. So it's not a tool, it's not a specific piece of technology out there, but a set of practices that sort of is meant to bring together and sort of make the work between developers or the development team and the operations teams, that's where dev and ops comes. And these practices are meant to sort of enable these teams to have more efficient and like more efficient work and streamlined work, and like more like productivity and all that kind of stuff, right? Because it's like a culture of, you're not just two individual teams that sort of only kind of just throw things at each other. You are meant to work together from pretty much the start and utilizing these practices. Before we sort of dive into the practices, does anyone want to add to just an overall definition of DevOps?
I feel like a lot of the time when we're talking about DevOps, and especially the roles of DevOps, there is like a lot of, like, as we mentioned, there is a lot of like uncertainty or misconception about the role. And again, like the DevOps engineer is a very new role on its own, because before it was like a operations engineer, or it was like a network engineer. Like there was a number of like separate roles behind, and now it's just like a way of having a more full software lifecycle centric approach, instead of having silos that are separated. And like, okay, I write code, you the QA tester test it, you the ops person put it in our build tool, you the networking person like do the networking for making sure that it gets to the servers or whatever it might be the case in a company. And it's just like creating a set of like shared knowledge and shared platforms, so that everyone can partake in most steps, as most of them are automated. So it goes from the beginning, the conception of the software, to the deployment as fast as possible and is as automatic as possible. And I feel like this shows up in a lot of other concepts that are the tools that are part of the DevOps practice, because they enable making sure that the software is delivered fast and there is a lot of automation available into these pipelines.
Yeah, no, I agree. And I think, like in the previous times, I think everybody was just an engineer, and then you would have like multiple teams of like who would code, and then you would have operations team, I think, and then a QA team just for testing. But as we evolved, there like the spectrum of things that you can do in a software development cycle has increased a lot, and has its own expertise, I think. And that's why you have DevOps engineer now as a term and a separate team. And I think their sole purpose, if somebody asks me what I do day to day, is just automating and making sure the software that's being written is deliverable really fast and reliably. I think that covers it up.
That's a good one-liner. Yeah. Do you all feel that? Oh, this might be a little off tangent, but the actual, when it comes to recruiting or to job listings, that the DevOps engineer role or the DevOps word itself is one of probably the most misused ones out there. Like right now, I sort of have this misconception, or maybe this feeling of like, if I see DevOps engineer in a role, I'm gonna be like, oh, you're probably expecting me to do a lot more than what an actual DevOps engineer is supposed to be doing.
I think I felt it when there were talks of moving me from cloud operations to DevOps. The first thing or first expectation kind of was containers. So there's this misconception, and I had that we might need to shift our workloads from the traditional apps to like have them containerized, which was not the case, but it's just a misconception. And I think every other job posting that I saw that had DevOps in the title need you to have Kubernetes or Docker specialization. And I even talked to my manager about this. I'm like, so we are not dealing with containers at all. He's like, we might in the future, but now our like sole purpose is just to automate what we already have. Yeah, and I think Antonio might have some good examples too.
Oh yeah, like I feel like there's a ton of like job postings that say DevOps, but are everything that is not right in the code. Like DevOps is you write the code and maybe you write the tests and then the DevOps team are the people that take over and do everything that is conceivable under the sun. And so one DevOps person should know like Kubernetes, infrastructure as code, should know containerization, should know like which sure like they're all part of the DevOps like practice, but it's really unlikely that one person can handle all of that on their own. Like I know people that are just very specifically well versed in infrastructure as code, and that's what they mainly do. So they manage a lot of like Terraform related stuff. That it means that you have to know like have a grasp of like underlying services and similar, but doesn't mean that you have to configure specifically every single one of them. Maybe like there are situations where you have to like maybe higher position, like the higher you go the more you have to manage a larger group of people, then more work closely with all of the tools. But I don't think that like the DevOps roles that you see like that entry-level DevOps roles or like junior career of DevOps roles, they expect you to have so much additional knowledge that either comes with the job or it's just really hard to have when you have never really touched like real large system. Like I don't think you get out of college, say, and you are a Kubernetes administrator or developer. I don't think that's gonna happen. So having that in like a junior DevOps engineer experience with Kubernetes is like, yeah, sure.
Yeah. No, and I agree. Like with the Terraform stuff, that is something that I experienced myself. Is I know I sat my certification last year, but I didn't have like production scale experience or exposure. And finally this year, like all our projects are basically standardizing all of the infrastructure as code and making sure we use Terraform because it's usable across various cloud providers. And it's just like once you are in, you just need to know some principles and some concepts, and the rest you just learn on your way. And I have been like really good with CloudFormation. It's just that bringing those same design principles and making sure like follow the best practices into Terraform. So I don't think like tools matter that much. But yeah.
some of the DevOps practices are easier to get hands-on like personal projects, like CI/CD, version control, obviously with Git, and even infrastructure as code to an extent. But then I think like there's not a lot of people who are gonna have like maybe monitoring. Like it's like one of those things that we don't like want. And it's not like we don't want to, but we don't immediately think to implement. Yeah, right. So like, and monitoring not only like the application but the infrastructure, right, and like real time data and that kind of stuff, and then also configuration management. Like, I don't think, like on a personal project, how do you have any ideas on how would you would implement it?
I mean, you can do like I don't know, like a puppet or like a chef, like scripts and like do it on a toy project. But like when you're deploying a personal project, that likely goes, I don't know, you deploy it on Netlify or Vercel. Like all of those things are done for you, and there is no reason why you should be ever care about configuration management. And same thing with monitoring, like unless you blow up with your application and then you actually have to start implementing monitoring, like I don't think any project starts with setting up like appropriate monitoring. So it's really hard to get like, and even if you were to start and implement like a very proper level monitoring, the sheer volume of like traffic that goes through a certain website that is just like a personal project is never gonna make it so that you have like production experience, because there's not gonna be the flow of like you don't have to, there's not enough traffic to force you to like start like implementing like scaling strategies based on the monitoring that outputs that you get. So even if you set up the monitoring, you still don't get the monitoring experience. So obviously there are some things like monitoring, configuration management, and a lot of these that are really only doable on a job. Like you can do it on their own personal project unless you start your own company and then you start getting traffic, and then at that point, yeah, but no one is going to start a company just to learn monitoring, really. So I mean, you can if you want to, but I don't think.
Yeah, no, yeah, it's really hard, especially with monitoring. Like config management, I don't know, you can try a few things, I feel like, but yeah, with monitoring, it's really hard, especially as I said, like I've been working with like I think Datadog and PRTG and other big tools for monitoring, and they get expensive so quickly. Like you're just monitoring an API endpoint every 30 seconds. But because this is a production scale app, you have millions of users, and the amount of requests you get, it count towards your costs. So, and to Antonio's point, you won't get that much traffic that, like, I haven't seen my, like notes site or my blog site being hammered, and seeing my EC2 instances not handling those requests. I don't know. Yeah, you basically can't get monitoring experience. To some extent, you can, and that's also because you might use the inbuilt monitoring that cloud providers come with, just to get used to like what are the things that you should be looking at when things go wrong. But yeah, other than that, like third-party tooling, I don't feel like it's worth it.
Yeah, and I guess we could sort of dive a little deeper into monitoring, and maybe this will be a concept on its own for this episode. But I feel like it's easy for you to implement sort of good practices with personal projects, but to actually get any substantial data, it's like, what are you gonna just like visit your site every single second for the day, like you personally, and to pull data from that, and like, or are you gonna blow up your app? I mean, I guess you could, but and then to get sort of like your production exploding, and you get actual use out of monitoring, like.
I do believe that there are some services that do like synthetic traffic, and you can just create a synthetic traffic. Like for example, what you could do is like and I don't know if that will work properly because that's a specific environment, but do things like end-to-end testing, where you do browser automation and you actually go through specific like clicks through your own application and do that, and that will create that would create like traffic, and that would go into the monitoring. But again, monitoring it's such a large scale. It's very very useful only a very very large scale. Like useful, it's you're always useful, but it's like vital and like it's extremely important to know mostly when the scale becomes very very large, because otherwise most of the tools that you deploy stuff on already implement some degree of monitoring automation for you. But I guess, yeah, we can discuss a little bit. Like, we've been discussing a lot of monitoring, but we didn't really say what monitoring is on its own. Actually, that's
Yeah. All right. So monitoring is sort of setting up like real time visibility into not only your applications but also the infrastructure that's running those applications. Rishabh mentioned, I think he said Datadog. I've used New Relic, and then obviously Azure Monitor. I think someone said CloudWatch at some point, right? Yeah, and I don't have extensive experience. I use New Relic mainly for infrastructure stuff, like for our really old VMs.
Yep. Prometheus and Grafana.
Oh, that's right. Yeah,
Yep.
that's right. Those are also other super popular ones.
So yeah, I think monitoring basically, yeah, as Gwen said, is like from a visibility perspective and also observability, because you want to make sure if it's a production scale app, you are able to observe what's going on when there's peak traffic, not just from the infrastructure perspective, because that's what we think, especially when we are in cloud, but also from like the application point of view, because I know like we have set up 3 or 4 just like health check endpoints in our app that monitor basically like some microservices to just check if they are running as expected, and not only our infrastructure is up, because sometimes your infrastructure might be running fine, but there was some faulty code that was pushed out and your service is down. And this has happened more times than I want it to happen. So yeah, I think that describes kind of what monitoring is.
Do you have, just because I'm curious, or like because you pay attention to a lot of this, we were just talking about you being like, you have to be on call, like it's part of your role. If there is an issue, what's your workflow with monitoring? Like, what's like the first thing you check, or like how do you go about it?
So the first thing is like receive a call.
Always in the middle of the night. It's always
in the middle. Yeah, because when you're working, your team or someone is already like looking at stuff. Whereas when it's in the middle of the night and you're on call, you'll see a call. My first thing is I have AWS app installed on my phone. The first thing I do is look at like CloudWatch and the CPU stuff, and this is just from experience and the way our app is managed. We have had some issues with like high CPU usage, and like auto scaling stuff was not in there. There were no auto scaling policies in the past, which have been dealt with, but there's still some cases when, like, because we do have certain limits on the upper side, that only like 10 instances can be launched because we don't want like hefty bills. And yeah, from CloudWatch, if I don't find anything, I unfortunately have to get up and get to my desk. And our go-to tool is PRTG and Datadog. So the alert, how I receive a call, is also generated through PRTG with an integration with another tool. So PRTG is the one that always like is the first one to report what's going on. So I open it up, see what the error is, and it also like gives you a brief error message if it caught any error messages in the log, just the way it's set up. And if I don't find anything there, Datadog is my go-to because it like monitors our APIs, it monitors our infrastructure. It also pulls a lot of data from like CloudWatch from AWS. It also, we do have like a hub kind of thing in our tool. So it also monitors every single connection that has been made and might be utilizing a lot of resource to our app. So yeah, that is my go-to kind of when I get a 3 a.m. call. Yeah, and then we also have some other tooling for log retention and stuff, where you can write a simple SQL statement to just get what's going on and get a live tail of what's happening with the requests.
All right. Pretty cool. Pretty nice look into the inside of a person who's on call. The only experience I've ever had with monitoring is we used to have these SQL servers, and they didn't have any like proper like balancing between. It was just like one server, and their answer was always to like, oh, just add more storage and RAM. So it and like every night it was like, oh, it's either gonna like reboot itself, because they would set like, I think the like some SQL that's like SQL tasks are scheduled in the middle of the night because no one was using it, I guess, or no customers were using it, to update data so the data would be available in the morning. And then it's literally, so it's like, 40%, 40%, 99% freaking triangle up, and then all the way back down. And then at that peak, it was like, it's either just like 50-50, it's going to turn off or not. And then the goal was, all right, just upgrade the RAM, like add more RAM and stuff like that. And set it, because in order to sort of like use another machine, you'd have to architect that stuff in that way. And it just wasn't set up that way. So yeah, it was just like, oh, it's that like one server. And then each time, because there was more data coming in, more customers coming in, it was just, just keep adding it to until whatever. Yeah, but it was, yeah. And then I would wake up, because you have like email alerts, and I would just always expect them to come in. I'm like, all right. And also kind of remind me of like, well, what's the point of having these email alerts if we're not going to address the actual issue? But yeah.
Yeah, no, that reminds of me like a really good issue that we had, really similar to SQL outages. So we had like a couple of sprocs, or stored procedures, just like same architecture. It was just multi-tenant. Someone decided it's good to have those like at the middle of the night because nobody's using. Turns out those procedures kept on growing as the app grew, and it turned into like so many procedures running at 12 a.m. that the CPU would spike like really high, and me and my coworker, we would be alerted around like 1 a.m. or 2 a.m. and we were like, what's going on? Because the infrastructure was for NA customers. So we have NA and EU, like different infrastructure for different side of customers, and like we were like, nobody's using the app. What's happening? And that's when like my coworker found, he's like, oh, it's all those new procedures that might be added, and they're running at the same time, all of them. Yeah, so we had to like segregate them. Like this one runs at 1 a.m., the other one runs at 4 a.m. But yeah, no, we definitely need to find like a proper solution, because otherwise you're just you'll keep getting the same alerts every day, and it ends up like, sometimes what I do is I when I see an alert that I already knew what's going on, I won't even like get up and look at it, because I knew, like I would know it would go away until like 3 a.m. But yeah, and there's no point in getting alerts if you're not fixing like the underlying issue.
Yeah, true. You just dismiss them.
Mm-hmm.
And yeah.
Yeah.
Anyway,
Yep.
Alf, you got any monitoring disaster stories?
Actually, not really. Like, I never had... Like, I had some times that they are dependent on other services going down. So recently there was like a Snowflake outage, and that ruined a lot of like our like a lot of like our work, and so they broke down a few apps here and there. And even in the past there was another Snowflake in my previous company, another Snowflake outage that ruined a lot of workflows because it broke in the middle of the night, which is when our data warehouse we used to rebuild, and it does like a wipe before it rebuilds, I think. So it basically wiped everything and it didn't rebuild it. So that was one fun situation, because a lot of like the overnight workloads like just weren't because there was no data, so that was a little bit fun. And we discovered in the morning. So, but at that point we just rerun it because the Snowflake is separate from the actual data like source, like a admin data source that was in Google Cloud, and it was stored like it's a transactional database. So all of those were just like models that were rebuilt on a daily basis based on that transactional database. So it wasn't too bad of a deal.
Okay. Well, I'm glad we all didn't lose our jobs because of outages. We should do an episode on sort of these like disaster experiences that we've had. Because I do have a few. Oh gosh, and it's nice to kind of look back because at those moments you're like, oh my goodness, what am I gonna do, kind of thing, right? Yeah, but anyway. We should save like on-call disasters and disaster event. But anyway, let's move on to another. We covered DevOps. We covered monitoring. Which one do we want to do next? Like, I could
talking about disaster.
Yeah, there we go. Smooth.
Yeah, let's talk about disaster recovery. Yeah, so it's pretty self-explanatory, like the word itself. Like, whenever there's a disaster, how good is your like recovery plan to get back up and running? And the disasters can be of like different types. Natural events, so maybe, as Gwen said, a single tenant app running one SQL server in one availability zone in a region. Let's say there's I don't know, tsunami or an earthquake, and that region goes down. You have to stand up a new SQL server in another region. So how good your planning and recovering of data is, it basically means disaster recovery. And also not only like natural disasters, but cyber attacks. What else could be?
Someone deletes something by accident, or someone does something on production when they're not supposed to. A setting was changed. I don't know. It could be like a bunch of things. Yeah, it's the actual plan. Like, what's your plan if this thing hits the freaking fan? That's what disaster recovery is. And I also feel like this is something that may be overlooked because maybe we think it's like, oh, this has never happened to us kind of thing. But then when it's like time to like stand up another SQL server, you find yourself, oh, we have to do it from complete scratch. We got to find the image. We got to get the right VM. Oh, what size is the correct VM? All that kind of stuff. So having all that planned out where it's like just like sort of like a push of a button to sort of replicate the infrastructure, that is what disaster recovery is. Rich, have you got any interesting stories with this?
Not from like disaster recovery point of view, and that you brought up a good point. Like we don't take it seriously until it happens. And like, yeah, I feel like we didn't have a particular plan in mind, but there was a situation where we needed our app is kind of like multi-tenant, but we only have it in like 2 regions right now. But then there was a business demand to have it in the 3rd region, and nothing was automated, so we have to like stand it up all from scratch, which brought up the discussion at like a bigger level of like, okay, this is the time when we need something so that it's like just 1 or 2 clicks maybe to deploy it to a new region. But the business took it from point of view that, oh, what happened if so we have it in North Virginia. What happened if there's like a fire in North Virginia and the data center goes down? So we don't have a plan. Like you would need 2-3 days to stand it up from scratch. And like that perspective of looking at it, like changed the entire automation process that we had in place, that we were still building. But yeah, I think we don't really have I don't have a really good story about it, but we do have a really good plan now. And I think I like really learned a few like key concepts when you're making the disaster recovery plan. So like you need to make sure you have like a dedicated team. In our case, like we were 2 engineers who figured out a plan, so we were the recovery team too. You also need to figure out like risk kind of evaluation of how much risk is involved. So like how much important is the data to the end user, right? So in our case, it was like, I think we retain up to 5 years or 2 years, something like that. And that is like listed out in our contract. So we need to make sure whenever there's an event like this, we should have backups. We should have that data available, not readily, but it should be there whenever the customer asks. So risk evaluation, and then also like there were two key terms in disaster recovery. So like
I was
RPO,
about to.
yeah, RPO,
I was about to say that. Yeah.
and RTO. So recovery time objective is the RTO, and then RPO is recovery point objective. So how often do you take your backups? So let's say in our case, it's every hour. So if anything goes down, we at least have like the last hour worth of data. So you're not losing a lot of data. And then RTO is basically how much time it takes us to recover that data. So that's, as I said, we keep up to worth of 2 years of data until the last hour. How much time it would take for us to like stand up a new SQL server, migrate all that data to the new SQL server, which I think is kind of around 3 to 4 hours for a SQL server right now for us. But yeah, those are some key terms with a disaster recovery plan when you're making it out. And I think like I really thank my team. I got the opportunity to work on it because like these things are really critical. And then also comes the I think the hardest challenge that I faced during this plan was the testing. Because how do you test a disaster
blow
recovery?
the whole thing up to
Yeah. And
Chaos monkey.
like the amount of time goes into testing is just nuts because like you have to destroy all of your infrastructure and then starts the whole mess of like recovering it and bringing it back up. But again, it's a crucial step. But sometimes companies neglect it because they're like, why would we do this? Because like whenever it will happen, and then we can test it out.
But I have an interesting story because so disaster recovery isn't specific to just cloud. It's just any infrastructure in general, even if it's on-prem. I can't remember. I think help desk role maybe, but there was a technician working on the battery of the generator, so the backup power if the building lost power or whatever but that one was specific for the server room because we all know servers need to be powered. If there needs to be some sort of like plan, if the power goes out of the building, the server room needs to be on, because that room was in charge of all the like on-prem file shares. So the way everyone, because it was you have HIPAA stuff that you have to deal with, so you can't just use like Dropbox or like just like some USB flash. Like you have to, like, these things have to be very secure, and there's like compliance and all that kind of stuff that you have to. So they had like really specific on-prem file shares, and they run their phone systems through there, their printers, everything was running through there. And this person made some sort of mistake and caused the whole server room to go down. For I don't know what happened. I think he tried to he was trying to kill the power and see if the generator would kick on like right away, right? So then I'm help desk, like within my first couple, it was the first week that I got that help desk role, because I remember making a joke at it, like when they were like introducing me to the whole team. I'm like, hey, it's my first week, but I had nothing to do with the power going out, kind of thing. Yeah, so I remember that. And then I remember sort of like the senior network engineer comes in because he would work remote. He lived like not like close, but he came in like running. He's like, what the hell happened? And then I think someone got fired. And there's the thing about like these kinds of things is like there's a lot of reporting that comes out of it. You have to give a complete detailed report because you got to think money is lost, clients are lost, especially with like data is lost. You don't know, like, okay, like, and with it being sort of like in the healthcare industry, it's like, what intake did we lose? All that kind of stuff, right? Yeah, so that was quite an interesting experience. But yeah, disaster recovery is, I guess, and if you have some sort of tech, whether that be cloud, whether that be on-prem, you need a plan. Absolutely. Yeah.
Oh, that reminds me of, we had challenges with GDPR, since I said we like host application in Europe. So we have a lot of European customers. whose data, and we were like, so now we need to figure out another location where we need to have backups. But yeah, no, interesting stories.
Well, in more like joyous discussions and less about the drama that could it. I feel like we one of the like field rouge, like one of the things that we discuss all the time when talking not only about DevOps, but like code in general, and we discussed this even earlier, is about version control, and a little bit. This is like probably the easiest thing to learn in the DevOps context. It's because if anything, like the tool itself could be used even if you're not writing code. Like think about when you're writing. Okay, so like one of the best ways I learned to think about like version control is think about when you are in school and you're writing an essay and you start saying essay like version 1, like draft 1, and then you add another one and then you say draft 1 with extra chapter, and then you go ahead and then you say draft 2 and you remove the extra chapter and similar, and you always like at the end, like after like hours that you work on something, you're like, oh dang, I really like the paragraph that I was using before. Either I save all the files or I don't have the file because I worked on one single file all the time. How do I go back? And that's basically what version control does for you, and it's basically a way of checkpointing your work throughout your life cycle or whatever you're doing. It doesn't have to be code. You can technically checkpoint files as well. Like if you're working on a Photoshop thing, technically you could do the PSD and just commit the PSD all the time, and then you can retrieve the previous version of the Photoshop file. Or you can do this for anything, and it's just a way of like being able to go back in time or move ahead in time, or just like branch out. And I guess like we can discuss a little bit about the key concepts, about version control, because there are a few terminologies that are thrown there, and you were like, oh my god, what's the difference between this and that? And who wants to give a stab at the first ones?
Version control is let me just add this, it's like one of those things that has just like so many features to it. Like there's no way to know. Absolutely. I feel like you develop a really good understanding with like a couple of the terms that we're going to talk about, but then this probably doesn't even cover like half of what's available in terms of like specifically we'll be talking about Git because it's like the most popular one. There are others out there, but I think we all use Git in like professionally, right?
Yeah, I there are a few others that are like known, but I don't think that really is as popular. Honestly, I feel like it's the most widely used. I think I don't even remember the other two really. Honestly, there are two very like famous versions. Like famous.
Does one start with an S?
Yeah,
like one starts with a T.
Oh.
Yeah, I don't honestly. I am. I have it on the tip of my tongue. I'm literally so annoyed because I am.
Someone needs to Google it while we and I can like jump into a couple of these terms while someone looks for it. But
yeah, whatever. It's annoying, but I have it. I have literally on the tip of my tongue, and I can't think. Subversion. That's it. That's one. One is it's called Subversion. And the other one is called Mercurial, I think. And there is also another one that is called, I think, SVN. Those are the major ones, I believe.
There's also one that was like super popular before. I think it was a Microsoft one. Do you all know before like Git became the popular? I'll have to Google it later.
Yeah, I know that there is the like Subversion is the one that is like the Apache one, and Mercurial is like, I think it's like I don't even know, like honestly, like I never really used it ever. And I mostly I use the Git all of the time. I know Subversion, I know Mercurial, but I never really tried anything else, really. Like, there's no major reason why you should do that.
TFS? Have you heard of TFS? I feel like it's that. Anyway,
The thing is that they all share the same concepts because it's the same like approach. I guess they just use different flavors of doing things. I wouldn't even like be able to point to why what's the point of having different ones. Like, what are the major differences between the various ones? Like, so it's so it's so Git is so ubiquitous that like I really don't see a point of having other ones because I don't see what benefits they would provide on top of like the things that Git provides. So that's just saying.
it's one of those service. I think it's maybe like one of the few things in tech. It's like, oh yeah, just Git. You know how when people ask like which cloud should I learn, and we're like, oh well, it depends, and that's kind of like the answer for like every other area. But with version control, it's like, yeah, like you said, I can't even think of why I would like what questions I would ask you to sort of give you a different answer than Git.
Yeah, and I think it's due to the popularity. Like, I don't know if there was any survey held by any other company. There might be, but I think like it's so much popular.
But I guess, yeah, again, like as we mentioned, the terminology, underlying concepts are the same. And I guess the major, like the ones that you may have heard the most are things like repository, commit, branches, pull requests, maybe pull requests and issues are more GitHub related stuff.
Yeah,
like
or
they
I
are
meant to say like pull request or merge request /
yeah, merges and pull, I guess you can say. But then merge request and merge and pulls are like more in the how do you do it so that you're in a when you're in a team, so that like you don't just like push that code to the thing. And I guess then like there's like a lot of like famous commands that you may have heard of, especially when talking about Git. And another thing that a lot of people have confusion about is like the concept of remotes. And I guess that we can start from like the basic thing, like the repository. It's just like the repository is a folder. It's a folder with your files, which has also another subfolder that is normally hidden in your file system. It's called .git if you're using Git. We're gonna okay, let's assume that we talk about Git. We're using Git. Okay, there is this little subfolder that is called .git that basically holds basically a ledger of everything that happened to your code. And that you commit. Like, it doesn't track it automatically. You have to intentionally say, okay, at this point, save the progress. Like, make sure that you remember what changed from the last time. And I'm gonna cut this. Make sure that you know what changed from the last time, and you do that through a system that is called the commit system. And basically, every single time you make a change to a file, Git in the background makes what is called a diff. Basically, just checks what a file is and what a file was, and looks at the differences. And then when you say commit these changes, you're saying, okay, I'm gonna in my timeline, like there is a timeline that it keeps track of. In my timeline, I'm gonna know that from point A to point B there was these changes. And those are the diffs, basically. And basically, you can go back and forth between these diffs. Like, if at a certain point in time you say, oh, I committed something that introduced a bug in my code, given that you are keeping this ledger, this timeline of differences, you actually can go back to a previous point where you know everything was working. That's how the beauty of Git works. Like, it's the fact that you can always go back to a previous version and previous state.
And it has saved me a lot of times.
Oh yeah, I has killed me a lot of times too, because I was on which also brings us to the branch topic. I thought I was developing on a certain branch, and I actually was working on another one, and I committed I wasn't main, thankfully, but I was working on another one. Like I had two branches that I was working on for two separate sets of features that I shouldn't. It's not like a very good practice, but I was working on a bunch of other things. At a certain point, I'm bored. I want to work on something else. I'm gonna switch to another one. And then I was committing changes from the one part to another branch, and then that completely like messed up everything. And I'm like, okay, I gotta redo my I gotta do everything from scratch because it's a little bit tricky to go back. But basically what a branch is like, okay, let's say that this point in time I wanna try I wanna make changes, but not to the code as it is. I'm just gonna make a copy of this code and work from there. And when I know that new set of code that I'm creating is okay, I can merge it back to the previous version that I was like, okay, leave it here at this point in time, work on other things, do your own stuff, and when I'm happy, I'm gonna go back and copy every new changes that were made into the original timeline. Basically, think about, I don't know, like the TVA or something. Git is the TVA basically.
Mm-hmm. And I think that brings up a good point. Like you covered two terms, branch and merge. So given that Antonio created a new branch and he was working on that, the reason why this is used a lot in companies is now I can go and create a new branch and work on that sideways to what Antonio is doing. So these two features can be independently worked on, and we are not able to mess each other's code. And then the common practice I see in big organizations, and it's like a best practice kind of thing, is you need to have a merge request before you can merge your code to the main or whatever the branch you pull your branch off. And in order to get it approved, you might assign other engineers that might put a stamp of approval on it and say, okay, yeah, this looks good. The changes you have in here are good. And then it all involves the other teams that might want to test it, like QA and stuff, to test it in dev staging kind of thing, and then can go out to production. But yeah, just covering the branch and the merge kind of two terms that are really important when working in teams.
Where GitHub and GitLab or Bitbucket, all of these services come in, are in providing you those type of create manual checks, test automatically my code. Those are services that are not inherently part of Git, but there are services that are around the use of Git, because they simplify your working in a team, working in people working on the same code in different machines and similar, without interjecting each other, but then providing you the tools to put together the code that you were trying to ultimately build together. And that's the remote also that comes with in. Basically, is when you host your repository, instead of doing it on your local machine, you can just host the repository in a remote repository. Like, for example, GitHub is a remote repository. You basically just say, every single time I want to push a change, I'm gonna say just take the code that is on my local machine and just push it out to the remote repository that is hosted by Git, so that the code that I built on my local machine is now available in the remote repository in GitHub, Bitbucket, GitLab, whatever it is.
Mm-hmm. And I'm trying to remember the other word it's used for the same thing. Remote. What else do you call it? I see it in...
There is origin, but that's a term on, it's a term of saying where is it coming from. Usually that's I don't think it's necessary to call it origin. It's just I believe it is a convention that is called origin.
Yeah, I don't know. Always I see, most of the times I see it's either local, let's say I'm working on my main branch And so I would see a version of my main branch locally, and then I would see origin, which most of the time refers to what's remotely available.
It's I'm reading now, and it says the main branch should be considered origin main, and Git origin is a shortened name for remote repository that a project was originally cloned for. Origin is by no means a magical name, but just a standard convention. So you can call it whatever you want. Technically, you could call it GitHub to know that you're pulling from GitHub or whatever, but it's actually just a convention. It's just like a way of referring when you're saying push, because potentially you can actually have I think you might have the possibility of having multiple remote repositories. Like you already have one, and you can add another name, and then you say pull from origin or pull from another one.
I see. Yeah. So this whole discussion kind of proves like how big origin controller Git can get.
Oh yeah, it's a very intense thing. It's intense to learn, but it's like one of the very vital skills that are no matter which type of developer you might be, or engineer, or any like DevOps engineer, whatever you are. Git is like one of the tools that you have to know, and we say Git by meaning version control, but probably it's Git that you have to know.
Cool. Wanna do the next two? Or
I guess we can speed run the last two. Like I feel like it's a very simple, like it's a concept that everyone hears about, especially recently. Like with it's
trendy.
The new. It's trendy, but it's also like the new way of handling like growing teams and growing developer teams, growing engineering organizations, and very, very large companies needs that need to scale very large. And it is containers and microservices. Does anybody want to try, let's say, what a container is?
The DevOps engineer.
No.
Okay, I guess. Okay.
No.
Okay.
You're exposing me.
Okay, so like simple terms, if you think about like a virtual machine, like a computer inside of your computer, basically a container is just the code and the dependencies that you would run on like a virtual machine without all the underlying extra code, like the kernel or all the things that make an operating system run. All you need to do is running on you need just the code and the dependencies that your code needs to run appropriately, but it will use the underlying machine resources and processes and the kernels and similar. So it will just run in a secure environment, because it's gonna be basically it's gonna be like the easiest way of thinking it is like an app on your phone. It's not that every app on your phone downloads iOS. Like if you're on iPhone, every app needs every app relies on the fact that it's running on iOS to run, and it doesn't need to ship with like other things like iOS compatibility and similar. So basically a container is like an app on your computer in its all of the code that it needs to run and similar, but it uses the resources of the computer to do that. The most famous container way, like the way of building containers, is using Docker. There are others that not a lot of like I don't know a lot of them really. Like Docker is similar to Git. It's like so ubiquitous that really Docker is one of the ways to go. And I guess that the key terminology that would be nice to know about containers is like a lot of the time you hear containers or images and similar. Basically, when you're creating an image, you're just creating a recipe to build up code in a specific way, and a container is basically an image that is being built and run. When you run an image, you are creating a container, but an image is just like a recipe, basically. So we actually have to download an image and build it, and then running that build, that output from that image, and that is a container. And the reason why containers are so used and so useful is because they are very, very lightweight, because you don't need to ship all of the underlying dependencies again. You just need to ship the code and whatever, like, I don't know, the packages that you need to run with, like npm packages or whatever you have if you have like a JavaScript project or similar. Also, they are very secure because Docker provides like all of the securities for making sure that the container runs in its own environment. It can't be can't spill out in the underlying machine. And also the fact is, like, given that they are based off like these images, you can build as many of them as you need to. So if one container dies, you can just immediately do it, recreate another one very quickly, which actually brings us to the next topic, which would be microservices. What are which is, and does anybody want to just try explaining a microservice?
I feel like you're the most.
Yeah.
The one who knows the most about
Ooh,
it.
that's a lot of. Okay, so. Okay, microservice, like the difference between, like when someone compares architectures of software, they compare usually monolithic applications, which means that is one code base and everything in the code base runs as one piece. And that's if you are like a Rails developer, or if you ever worked with Ruby on Rails or other tools specifically. I'm thinking Ruby on Rails because that's the most common one, really, the monolithic. Basically, all the code base is inside of one. All the code is inside of one code base. If one piece goes down, it's potentially the entire application that goes down. And the alternative way of doing that is having a lot of very, very small services, microservices, that are very, very, very specialized at doing one thing and doing that very well, and without caring about what other things are doing, like what other neighboring services are doing. They just know that they accept one input, and you're gonna get this output based on the input. And basically, what this helps you do is multiple things. One, it helps you make every single service deployable on their own. So every team that maybe works on a specific service, say that you are Netflix and you have a service that gives you a suggestion on like what is the next movie that you want to watch. You can be your own team and you can deploy that whenever you need or make updates whenever you need without having to ask, for example, the team that handles the streaming portion or like the interface to do anything, because you have control over your own microservice and you don't need to integrate with anyone else, really.
So like independently deployable.
Yeah. And this is also means that they are loosely coupled. Loosely coupled means that there is no dependencies from a service to a service. Like service A, like of suggestion, I don't need to rely on any other service to work. I know what I want. If you ask me something, I'll answer, and I don't need to know what the other person thinks or what the other service answers or similar. So it's very easy to think about what are my mentions and like what do I need to do and so that means that you don't have to care about very, very, very large architectures, but you have to care a very, very specific set of tools or needs, and that also means that it's very maintainable and testable because you just have a very small number of things that you have to care about. But the problem with microservices is that there is a lot more work that you have to do to sustain this, because you're talking about distributed system. Like, given the fact that you want to maintain loose coupling, it also means that I don't need to rely on an answer. Like, I don't need to expect an answer from another service to work. I should work even if the other service goes down, which is good, because think about like Amazon. Say that they have a microservice that handles lists. It doesn't mean that if the list service goes down, I can't add stuff to my cart, because they are independent of each other. But if I have like the same like a product page, say, and I click add on list, it's just gonna tell me, oh, there is a problem adding to the list. But if I want to add to cart, I can add it to the cart, because they are loosely coupled. Like, they coexist on the same page. They can interact between each other. Like, say that I want to go from a list to my cart directly, they may coexist, but the fact that one is down doesn't mean that the other one is down as well. And this comes at the cost of maintaining all this asynchronous communication between these services, and it comes with Kubernetes. Basically, that's the major like runner of microservices. That is one of the hardest thing to master, and it's reasonable because it's like a very complex topic, because you're talking about distributed system overall. But also, one thing that a lot of people don't really take into account is how much more complex is the data modeling in a system based on microservices. Because the thing is that, given that you can't rely on other services, that also means that technically you can't rely on databases, because if you share a database and there are two services that use the same type of data, if one service, like let's say that I buy something and another system checks again, like has to check what is the last order. Like, I have a service that just gives me the last order that my company has ever received, and what if I rely on the same set of data? Then whenever I send like a new order request, potentially I'm out of sync with the data that my like fulfillment service needs. And that's a problem, because the thing is that if my service relies on a table that I want always the freshest data, how can I make sure that I always get the freshest data? And it's very complicated to think about this. I don't think it's a very beginner-friendly topic overall, because there is so much that goes into data modeling for the microservices. There are multiple patterns. One is like having a database per service. Like, every single service has their own database, and no one can touch that database. And whenever I do something, I'm just gonna broadcast to everyone and say, hey, I'm doing this. And everyone that needs to listen, that needs to say, hey, I need this type of data, just say, okay, thank you, I'm gonna take this event and put it in my own database.
So you need a synchronization between multiple databases.
Without synchronized, because if it's synchronized, then it means that they have to be relying on each other. You're just thinking, okay, I'm just gonna put it here and say, hey, I've done this. And then the people that need to do, like services that need to go, they go in like this like historical ledger of what happened, and thus they say, oh, I care about this, I'm gonna take it. Oh, I don't care about this, I don't care, and go and so forth. That's the hardest part about microservices, in my opinion, because it's like, especially architecting a system that is based on microservices, that is completely the hardest portion, in my opinion. Kubernetes is also the hard part, because it's organizing everything. But I guess it's interesting to know about microservices, because you, probably as a developer, you may be more interested about knowing that you can care about very specific portions of like the code, like what your code needs to do, and that is the most important part. But it is an incredibly complicated topic, but it's just great to know, because it's a shift, like it's one of the largest technological shifts in the past. So I think it's very important to be aware that microservices are a part of the potential work that you may do in the future. You don't have to be an expert off the bat.
You could probably get a little, maybe some exposure to it with like serverless functions to some extent. because that's sort of, I mean, everything is very modular and so microservices like already when you're deploying these functions. I mean, you're probably not going to get it to the extent of like what a proper microservices architecture, though there are microservice like architectures that are deployed with serverless. Have you seen that? There was like this tweet that went viral like last week or something, and someone was like, there's like this diagram with just like a bunch of lambdas and there's like 40.
Oh yeah,
Yeah.
You see that?
yeah. The Sean Wang like he posted it. That was pretty funny. Yeah.
Yeah, it was pretty intense.
With Charlie from It's Always Sunny from
Yeah,
Philadelphia.
exactly.
In
That's the one.
Philadelphia.
Yeah, you could. I mean, I don't think on a personal project you'd get to that extent, but you could get a couple, like the thing that we're working on with Rishabh has like 3 serverless functions on the back end, and then there's a front end that's independent too. So yeah, you could get some exposure with it, but yeah, never to the extent. I was just thinking like with microservices, you also have to deal with like scaling independently because some of them will be hit at like some of them might be more popular or higher in demand than the others, and then there's like messaging and queues that you have to deal with. All that, oh my goodness, all that kind of stuff.
Like,
Yeah.
Top of
It's
my
a
head,
lot-
I can think of like authentication is like a really good example. Like, what if it's down, even if it's not independent?
Yeah.
Like it's independent of other services, but
Yeah, there's a lot of like
complexity and
there's
caveats.
insane amount of complexities. That's why like teams that actually work extensively with microservices architectures and are usually very they have a lot of like engineers on a team because maintaining one is very complicated.
You know what I think might be an interesting show episode that sort of is around this is planning out, not actually building, but just planning out an app that we could build, and then sort of talking about the different services and then like what purpose they'll serve and that kind of stuff.
just a discussion.
Yeah, just a discussion like, oh, we're going to build
brainstorming.
this.
Yep.
Let's use this for storage. Let's use this for whatever and that kind of stuff, right? That'd be cool.
Honestly, that is a very common, could potentially be a very common interview question, like a systems engineer question or similar. So that's actually very
architect,
interesting.
yeah.
Like on system architecture, and that is a common thing for like a lot of like technical interviews. So that could be interesting to just have
definitely,
a chat on like, this is the app that we want to build. How can we do it? Let's discuss.
We'll have to put that together. But yeah, that was pretty solid definitions, Alf. You got both of those last ones. We covered a lot. This was pretty good. I was actually kind of worried that it wasn't going to be long enough, but we're pretty good on time.
Oh yeah, we are over time.
We could wrap this one up. This was fun. This one was fun.
All right. Well, I guess we would like to thank you so much for listening to this episode. As always, you can follow us on all our social media, on Twitter, TikTok, there's LinkedIn page, YouTube. And make sure that if you have any questions about like topics that you would like to cover, or any question that you would like to expand upon based on our previous podcast episodes, make sure to drop us a line on Cloud Code Life Twitter account. It's always checked, so you're never gonna be left out in the dark. And as always, thank you so much for listening, for your time. We really appreciate the response to all of these episodes. And now it's week 8 of this, so that's already more than 2 months. So that's pretty crazy. But that being said, again, thank you so much. We'll catch up next week in another episode of Cloud Code Life. And in the meantime, peace.